In the futuristic world of quantum computers, Chinese scientists publish more quantum-related research papers annually than any other country.
China is proving its power with a huge construction project that many say places it 100 years ahead of the United States. This project is not just big, it is changing how nations think about building, technology, and national strength. The scale alone has left experts speechless and the world watching closely. But what makes this project so different, and why is everyone talking about it? Join us as we reveal the full story. Building faster than time. In 2015, China surprised the entire world with a construction project that changed how people think about what is possible in modern buildings. A skyscraper was completed not over many years or long months, but in only 19 days. This project was named Mini Sky City, and it became a powerful example of how new ideas and smart planning can completely change the speed of construction. At a height of 670 feet, and with 57 stories, the building rose into the sky in a way that seemed almost unbelievable. It did not follow the slow, traditional process of building floor by floor on site. Instead, it showed how planning, technology, and careful preparation can work together to save time in ways that once felt impossible. Mini Sky City was not built using the usual methods people expect when they think about skyscrapers. The project relied on modular design, which means that large parts of the building were made in advance. These full sections were produced in factories, where conditions could be controlled and work could continue without delays caused by weather or other site problems. After these sections were completed, they were transported to the building site. Once there, they were assembled one by one, much like fitting together large building blocks. This method allowed the structure to rise at an incredible speed. Each piece was already prepared, so the workers only needed to stack and secure them in place. As the building came together, the speed of the process was so fast that it almost felt unreal. Watching a full skyscraper take shape in less than 3 weeks gives the feeling that the future of construction is happening right in front of your eyes. The project showed how careful planning before construction begins can completely change what happens during construction. By preparing the parts ahead of time, the builders were able to avoid many of the delays that usually slow down large projects. This approach also showed how modern engineering and design can work together to make large buildings safer, faster to build, and more efficient. What made this achievement even more striking was what followed. The same company responsible for Mini Sky City later announced an even more ambitious plan. They revealed an idea for a tower with 220 stories to be built using the same modular construction method. When compared to the 57 stories of Mini Sky City, this new project would be more than 4 times taller. This comparison helps show the scale of the vision behind the plan. It highlights how quickly ideas can grow once a new method proves that it works. In China, large goals are often matched with the determination to make them real, and this plan reflected that mindset clearly. The announcement served as a reminder that limits are often pushed once people see that something once thought impossible can be done. This bold way of thinking does not stop with skyscrapers. The same spirit of innovation can be seen in the way China approaches energy projects in some of the most difficult environments. High in the mountains, where the air is thin and the cold is severe, stands one of the most impressive power plants ever created. This site is known as the Kela Power Station. The environment around it is harsh, with freezing winds and temperatures that can drop to -30 degrees. These conditions make construction and daily operation extremely challenging. Yet, the project moved forward, showing how determination and planning can overcome even the toughest natural obstacles. The Kela Power Station is remarkable not only because of where it is built, but also because of how it works. Unlike many power stations that rely on only one type of energy source, this facility combines 2 powerful methods of clean energy production. It is not fully based on hydropower, and it is not only a solar plant. Instead, it brings together both systems in one large project. Across a massive area of 170 million square feet, huge fields of solar panels are spread out to capture energy from the sun. At the same time, strong hydro systems use the power of moving water to generate electricity. By working together, these 2 systems create a steady and powerful source of clean energy. The total energy produced by the Kela Power Station goes beyond 1 gigawatt. This level of output places it among the most powerful renewable energy projects in the world. It is also recognized as the largest hydro and solar combined plant of its kind. What makes this even more impressive is the setting in which it was built. The high altitude and extreme weather conditions make construction difficult and risky. Equipment must function in freezing temperatures, and workers must operate in an environment that can be physically demanding. Even with these challenges, the project was completed, showing that careful design and strong engineering can allow large-scale renewable energy projects to succeed in places that many would consider impossible. Standing against the forces of nature, the Kala Power Station represents more than just a power plant. It shows how innovation can adapt to the environment rather than be stopped by it. By combining solar and hydro power, the project takes advantage of the natural features of the region. The sunlight and water resources are used together to create a cleaner and more reliable energy supply. This approach also shows how different renewable technologies can support each other, helping to reduce dependence on a single energy source. When technology shapes cities, imagine a public park that covers nearly 60,000 square feet, created not by large teams of workers using traditional tools, but by powerful 3D printing machines. This is exactly what China introduced with the AICT 3D printed park. The entire space was formed using advanced 3D printing technology, with concrete carefully placed layer by layer to shape every part of the park. The benches, the sculptures, the flower beds, and even the retaining walls were all produced through this method. Nothing was built in the usual way. Each element was designed and printed to fit smoothly into the next, creating a unified and flowing environment. The final result is a landscape filled with smooth, wave-like forms that gently connect with one another. The shapes do not feel sharp or rigid. Instead, they move softly across the space, giving the park a calm and modern look. The design feels futuristic and almost otherworldly, as if the park belongs to a new age of building. What makes this project even more impressive is how quickly it was completed. Even with its massive size, the entire park was finished in only 2.5 months. This speed is remarkable when compared to traditional construction, which often takes much longer for projects of this scale. The cost of building the park was also much lower than what would normally be expected. By using 3D printing, China reduced many of the expenses linked to labor, materials, and long construction timelines. This project clearly shows that 3D printing is no longer just an interesting experiment. It is becoming a serious and practical method for modern construction in China. The park stands as clear proof that this technology can be used on a large public scale, and this achievement was only the beginning of what was to come. China soon pushed 3D printing even further with another major project. In Shanghai, engineers used this technology to create something far larger and more complex than everyday printed objects. Instead of small items like furniture or decorations, they built a full pedestrian bridge using 3D printing. The bridge stretches almost 86 feet, making it the largest 3D printed bridge in the world. This structure shows that 3D printing can move beyond small-scale designs and become a powerful tool for major infrastructure. The bridge was constructed in just 450 hours. 2 robotic arms worked together to produce the structure. The main span of the bridge is made from 44 hollow concrete units, while the curved handrails are formed from 66 additional pieces. Each part was carefully printed to fit into the overall design. The hollow structure helps reduce material use while still providing strength and stability. The curved handrails add to the smooth, flowing look of the bridge. The design of the bridge follows the same wave-like style seen in the 3D printed park. It blends naturally into the surrounding environment and does not appear harsh or out of place. Instead of looking purely functional, the bridge appears graceful and artistic. It feels like a piece of modern art placed within the landscape. Just like the park, this bridge was completed much faster and at a much lower cost than traditional construction methods. This project once again highlights how China is moving ahead in adopting building technologies that many other parts of the world are only beginning to explore. While these 3D printed projects are impressive, China's next achievement moves beyond printing and into the careful movement of massive structures. The Hawaii Shikumen complex presented a unique challenge. This historic landmark stood directly above the planned site for a large underground project that included a shopping center, parking areas, and subway connections. In many places, such a building might be removed to make way for development. However, the goal in this case was to protect the historic structure while still allowing modern construction to move forward. Instead of choosing demolition, engineers turned to advanced technology to solve the problem. The building, which weighs 8,270 tons, was carefully lifted using a large group of robotic hydraulic jacks. These machines work together in a coordinated way to raise the entire structure from the ground. Once lifted, the building was slowly shifted forward in small, controlled movements. This process looked almost like a giant mechanical walk, with the structure moving step by step. The careful relocation allowed construction to begin underneath the original site. The underground shopping center, parking facility, and subway connections could be built without harming the historic complex. After the underground work was completed, the entire Hawaii Shikuman complex was moved back to its original position. Throughout the process, the structure remained unharmed and intact. This achievement showed how technology can protect cultural heritage while still allowing cities to grow and modernize. Together, these projects highlight how China is using advanced construction methods to reshape how cities are built and preserved. The AICT 3D printed park shows how large public spaces can be created quickly, affordably, and with striking design using 3D printing. The Shanghai 3D printed pedestrian bridge proves that this same technology can be used for important infrastructure on a large scale. The relocation of the Hawaii Shikuman complex demonstrates how engineering innovation can protect historic landmarks, even as major development takes place beneath them. When engineering reaches new heights and buildings begin to breathe, this achievement stands as a new record in human engineering. Rising more than 2,000 feet above the valley floor, the bridge is designed to become the highest bridge on Earth. It will surpass the previous world record, which was also set in the same province. The location alone makes this project extraordinary. Building at such a height brings conditions that are far more difficult than those found in ordinary construction sites. The thin air, strong winds, and deep canyon below create a setting where every task becomes more complex and demanding. Nothing about this project followed normal methods. At this altitude, traditional construction tools could not perform the job. Regular cranes were unable to reach the work area, and even if they could, they would not have been able to carry the massive loads needed for such a structure. The scale of the bridge required a completely different approach. Faced with this challenge, Chinese engineers chose to create a solution instead of forcing old methods to work in an environment they were never designed for. Their answer was the creation of the largest cable crane system ever built. This enormous cable crane system was suspended high above the canyon, stretching across the vast gap where the bridge would stand. From this elevated position, the system was able to lift and place huge trusses with remarkable accuracy. Each of these trusses weighed more than 21,000 tons. Yet they were moved and positioned with careful control. Handling pieces of this size requires not only strength, but also extreme precision. Any small mistake at this height could lead to serious problems, so every movement had to be carefully planned and guided. The precision achieved during construction did not rely on physical power alone. Engineers combined modern digital systems with advanced navigation tools to guide every placement. They connected the Internet of Things with China's Beidou satellite navigation system. This integration allowed each massive part of the bridge to be guided into position with exact alignment. The technology ensured that components locked into place exactly where they were designed to go. This level of accuracy helped create a structure that is not only strong, but also carefully balanced and aligned across the canyon. The bridge itself is not just a static structure. It contains a network of smart cables that act as a constant monitoring system. These cables form a kind of intelligent web within the bridge, collecting data about the condition of the main structure in real time. The system watches for changes in stress, movement, and overall performance. This allows engineers to understand how the bridge responds to wind, weight, and natural changes over time. The bridge becomes a living system of information, providing ongoing insight into its own health and stability. What emerges from this project is more than a crossing over a canyon. It is a clear example of how far modern engineering and technology can go when they are combined with creative thinking. The bridge stands as a physical symbol of innovation, showing what becomes possible when limitations are challenged rather than accepted. It demonstrates that even in the most extreme environments, human ingenuity can find ways to build structures that were once considered impossible. The spirit of innovation does not stop with bridges. Another remarkable development can be seen in the way construction sites themselves are being transformed. Construction areas are well known for their loud noise and thick clouds of dust. These conditions affect not only workers, but also the surrounding environment and nearby communities. In China, engineers introduced a solution that is both simple in idea and powerful in impact. Entire construction sites are now being covered by large inflatable domes. These inflatable domes form sealed, air-filled structures that enclose active construction zones. Instead of allowing dust, dirt, and harmful particles to spread into the surrounding air, the domes trap them inside, The structure acts as a barrier that keeps pollution contained within the work area. At the same time, the dome helps reduce the loud noise produced by heavy machinery. The constant sounds of drilling, cutting, and lifting are muffled by the air-filled enclosure, making the surrounding area much quieter. Inside these domes, advanced filtration systems play an important role. The air within the enclosure is cleaned before it is released outside. Dust and harmful particles are filtered out, helping to protect both the environment and the people who live or work nearby. This approach changes the way construction interacts with cities and communities. Instead of being a source of constant disturbance, construction can now take place in a more controlled and responsible way. The domes show how engineering can improve not only structures, but also the everyday experience of people who live near large building projects. Another striking example of modern design and engineering can be found in the Fosun Foundation Cultural Center in Shanghai. At first look, the building appears to be a bold and modern theater. Its shape and presence already set it apart as a cultural landmark. However, a closer look reveals something far more unique. The building itself moves. Its exterior is made up of giant kinetic curtains, formed by 3 large bronze tubes. These elements slowly rotate around the building's facade. The movement of these bronze tubes is gentle and gradual. At first, the change can be easy to miss. Over time, however, the shifting patterns become clear. The facade continuously changes its appearance, creating new visual forms throughout the day. The building looks different in the morning than it does later in the afternoon. Light and shadow interact with the moving surfaces, producing an ever-changing display. When seen in time-lapse, the effect becomes even more striking, turning the building into something that feels alive, like a sculpture that responds to time itself. A new face of modern China. Some buildings feel as if they belong in the future. The Anji Culture and Art Center is one of those rare places that looks both modern and gentle at the same time. Its most eye-catching feature is the roof, which is shaped to resemble the soft and delicate form of bamboo leaves. This design brings a calm touch of nature into a bold modern structure. The roof is made from wide white metal panels that curve and flow in a smooth way. These panels are carefully arranged so the roof appears to float above the building, creating a light and airy feeling instead of a heavy one. This beautiful roof is not only about looks. The building also includes a sustainable rainwater recycling system. This system helps collect and reuse rainwater, and it cools the building in a natural, passive way. The design shows how beauty and practical purpose can exist together in one place. The Anji Culture and Art Center covers an enormous area of about 1.29 million square feet. This vast size reflects the scale of the ideas behind it. The center stands as a powerful symbol of creativity, culture, and advanced engineering coming together. The project is expected to be completed this year, marking an important moment for modern design in China. The Anji Culture and Art Center is not the only project changing the look of Chinese cities. In Wuhan, plans are moving forward for one of the most daring skyscraper projects ever proposed. This project is called the Phoenix Towers. These 2 towers are designed to reach an incredible height of about 300 feet. The taller tower is planned to become the second tallest structure on Earth. The height alone is impressive, but the vision behind the towers goes much further than size. The Phoenix Towers are planned as more than tall buildings. They are designed to function as massive sources of clean energy. The outer surfaces of the towers will be covered with solar panels that capture sunlight. Inside the towers, different energy systems will work together, including wind power, thermal systems, hydrogen fuel cells, and biomass boilers. These systems are meant to produce clean energy within the buildings themselves. This approach blends bold design with a strong focus on sustainability. One of the towers will also include the world's highest sky garden. This garden will sit at the top of the structure, bringing a living green space high above the ground. The idea of placing nature at such an extreme height adds a gentle and hopeful touch to an otherwise powerful structure of steel and glass. The Phoenix Towers will be built on an artificial island in a lake, which adds another layer of imagination to the project. Together, the towers represent a vision of future architecture that combines environmental care with daring ambition. The design is so striking that it is expected to draw global attention. China is not only reaching higher into the sky, it is also changing how cities work at ground level. A key example of this is sponge city landscaping. This is a modern approach to urban planning that aims to turn whole cities into living, breathing systems. Instead of covering the land with hard concrete that blocks water, Sponge cities are designed to work with nature. They include rain gardens, wetlands, green roofs, urban forests, and sunken parks as part of everyday city spaces. These green features allow cities to absorb rainwater like a sponge. When it rains, the water is soaked up by soil, plants, and special surfaces rather than rushing away and causing floods. This helps reduce the risk of flooding in urban areas. It also helps refill underground water sources and supports natural habitats for plants and animals within the city. The presence of these green spaces improves the quality of life by creating healthier ecosystems in places where people live and work. Several areas show how sponge city design works in real life. The Kuning Stormwater Park, the Lingang Sponge City Zone in Shanghai, and the Zhuhai Hengqin Free Trade Zone all demonstrate how cities can be shaped to handle water in a natural way. Even sidewalks in these areas are made with porous materials that allow water to pass through instead of pooling on the surface. The result of sponge city planning is urban spaces that are more resilient and more pleasant to live in. These cities are better prepared to deal with heavy rain and flooding. At the same time, they enjoy cleaner air, healthier natural systems, and green spaces that bring life into daily surroundings. Through floating roofs, sky gardens in the clouds, and cities designed to absorb and reuse rainwater, China is reshaping how modern development can look and feel.